So in this question here, I've got a curve with parametric equations, x equals 4 sine t, y equals 5 cosine squared t, with t's from 0 to 2 pi. Now what I want to do is find the equation of the tangent at this point here, 2 root 2 and 5 over 2. So where do I start? Well, I know for a start the tangent will be the derivative of the parametric equation. But also, as this point will lie on the equation, I can use these 2 points with my beginning parts here. So what I can do is, if that's my x coordinate, I can set this equal to x. So I'll have 2 root 2 equals 4 sine t. That's for my x coordinate. And then what I want to do here is solve for t. So divide both sides by 4. So I'll have root 2 over 2 equals sine t. Now that then will give me 2 solutions from 0 to 2 pi. So t will either be pi over 4, and the other one will be pi minus pi over 4, which is 3 pi over 4. So I've got 2 possible solutions for my tangent. So there's something to think about there. So now let's have a look at y. Now here I've got 5 cosine squared t, and I've got 5 over 2. So let's set those equal to each other. So 5 over 2 equals 5 cosine squared t. So let's solve for t here. So divide both sides by 5. So I'll get 1/2 equals cosine squared t. Then take square root of both sides. So I've got plus or minus 1 over root 2 equals cosine of t. So this is going to give me 4 solutions from 0 to 2 pi. But what I really want is to see if there's any that will match with these 2. So here I will see if I've got cosine t equals 1 over root 2. That's the positive version. I could have t equals pi over 4. So there's one solution. And if I also have 3 pi over 4, that will correspond to the minus 1 over root 2. So that would also give me 3 pi over 4. And there would also be 2 other solutions, which I won't need to worry about because they won't be at pi over 4 or 3 pi over 4. So these are the only 2 that I'm interested in. Okay, now what I need to do now is find my derivative and see if there's any difference when I plug in my 2 values of t. So for my derivative here, I need dy dx. So what I first of all need is, as my equations are in the form of t, I need dy dt divided by dx dt. So dy dt, so the derivative of that will be 5 cosine squared t. So bring the 2 to the front by the chain rule. So that'll give me 10 cosine t. And then by the chain rule I need to multiply by the derivative of cosine, which is negative sine. So that would be negative sine t. So that's okay for the dy dt. And now my dx dt, a bit more straightforward. So 4 sine t becomes 4 cosine t. So 4 cosine t. And then what I'm going to do is simplify this and set t into there and put it into here to see what I get. So I'll see here now, cosines cancel out and that becomes 5 over 2. So that becomes minus 5 sine t over 2. So now let's try pi over 4 and 3 pi over 4. So let's do dy dx, and for t equals pi over 4. So that gives me minus 5 sine pi over 4 over 2. So sine of pi over 4 is root 2 over 2. So that gives me minus 5 root 2 over 4. So that's my gradient at t equals pi over 4. That's basically what we've just calculated. So now I want to see if there's any difference at 3 pi over 4. Well, at 3 pi over 4, we can just do that pretty quickly. Sine of 3 pi over 4 is also root 2 over 2. So that's going to give us the same gradient. So therefore, my minus 5 root 2 over 4, that's going to be my gradient of my tangent line at this point. So to find my equation of my tangent, the equation I need is y minus y1 equals mx minus x1. So my y1 and x1 will come from the point that I know is on my curve. Then my m, that's now my gradient. So let's solve that. So y minus 5 over 2 equals minus 5 root 2 over 4. So minus 5 root 2 over 4. And then x minus 2 root 2. Okay, let's do some work on this. So that there, I can just leave that for the moment. But what I need to do now is distribute this 5 root 2 with these. So then I've got y minus 5 over 2. That equals minus 5 root 2 times x over 4. And then 2 root 2 times this. Well, the 2 and the 4 will cancel to leave me with just a 2 on the denominator. And the root 2 times root 2 will just give me 2. So that's going to give me minus 10. But the 2 minuses here will also make a plus. So that's going to give me plus 10 over 2, which is going to give me 5. So let's just double check that. So minus 5 times 2 is 10. Then the root 2 squared is 2. Divided by 4 is going to give me a 2 to divide by on the bottom. Okay, now let's see if we can simplify this off. So what I need to do now is add 5 over 2 to both sides. So then what I'll have is, I'll have y equals, so let's put this as, this is going to be our answer, y equals minus 5 root 2 x all over 4. And then the minus 5 over 2, bring that to this side. So I'm going to now add 15 over 2. And then we are done. That's the equation of our tangent line at 2 root 2, 5 over 2. Okay.